In the last section, we talked about finding cycles in a directed graph. Now, the algorithm we talked about there doesn't work for an undirected graph. Let me explain why. So here we have a simple undirected graph without a cycle. Now, if we run our previous algorithm, we'll put A and B in the visiting set, but because there is an edge from B to A, and A is still in the visiting set, our algorithm would think there is a cycle in this graph. So it detects a cycle between every two nodes connected by an edge. So here we need a different algorithm. We're still going to use a depth-first search, but as we're navigating in our graph, we should pass the parent of each node to its neighbors to prevent going back to that parent. So let's add another edge here and form a cycle. We start our depth-first search from any node. Let's say A. We put A in the set of visited nodes. Now we should explore the neighbors of A. We can go to B or C. The order doesn't matter. Let's go to B. Now, B has two neighbors, A and C. We don't want to go back to where we came from, right? So as we move from A to B, we should pass A as the previous or the parent node. Now, when exploring the neighbors of B, we know that we came from A, so we're not going to go in that direction. Instead, we go to C. Similarly, we pass B down, so we don't go back to it from C. Now, C has one other neighbor, but we have already visited A. So we have a cycle in this graph. Now, in this example, we started from A and all these nodes are connected. But what if we had a complex graph and some nodes were not reachable from A? That's very easy to solve. We need to start our search from every unvisited node in this graph. So we need a for loop. We iterate over all the nodes of this graph. If a node is not visited, we start a depth-first search on that node. So now I want you to implement this algorithm in code. Add a method called hasCycle to our weighted graph class. It shouldn't take you more than 15 to 20 minutes. So I will see you soon.